Hi there. In this video, I will give you a quick introduction to the Raspberry Pi Pico, the pinouts and the various features on Raspberry Pi Pico board, and the different variants which are available, the different models that are available on officially from various websites and various sources. If you go to the Raspberry Pi website and check up the Raspberry Pi Pico description and the details, the documentation, you'll find this document which I have actually shared on the sheet of paper here. The actual documentation, you can access them on their official website, the link to which I'll be sharing in the description with this video. To begin with, I think there are four models of Raspberry Pi Pico available in the market right now. The one which you see here is a Raspberry Pi Pico. This is a standard board. This board comes without the headers, like I have them right here, right? This comes without the headers as such. You can see that, right? You also have the one with the headers. It's exactly the same, just that the headers are pre-soldered. Like you can see the back and the front, right? So this with the headers, and this is without the headers. And you also have the Raspberry Pi Pico W, which comes without the headers or with headers. Apparently, I got the one without the headers and soldered the header on my own. You can see the imperfection of hand soldering on this particular board, however. So if you get one with the headers, it might look more cleaner and more nice. So, but it's fine. It just works. So I have the one with the Wi-Fi module. The way to differentiate it is that the Wi-Fi board has this extra Wi-Fi chip that's on this board, whereas the normal Raspberry Pi Pico boards don't come with onboard Wi-Fi. All right. So now let me tell you about the features of Raspberry Pi Pico as described in the official documentation that you can see right here. So let me just zoom this screen a bit. As you can see that the Raspberry Pi Pico and the Pico W and the Pico H, all of these boards come with the main component, which is the RP2040 controller that you see here. This is the controller, and this controller has its own pinouts, and these pins are apparently connected to various pins that you see exposed via headers in here, right? There are a couple of internal pins which are connected to internal circuitry, which contains its own built-in power regulator, and it's also got its own debug port and other stuff. So we can just ignore that for now. But for now, the main pins, which are mostly for controlling devices and connecting to sensors, are all connected to the headers in here. The Raspberry Pi apparently comes with dual-core ARM processor, as you can see here. It comes with the dual-core ARM Cortex M0 Plus processor here, and it's also got a USB 1.1 with device host support, which means that you can see this micro USB port on this particular board, and this is where you can connect your micro USB connector here, and you can connect it to your computer and upload your programs, access the file system to store and retrieve programs from your Raspberry Pi Pico. But you can also have the host control where you can actually connect to other devices if you want to, and communicate or USB. That is also possible on this. And it's also got a low power sleep and dormant modes. It's got a built-in support for power management, which means that when this device is not being used, when nothing is being programmed, it automatically goes to low power mode. So this power management is built into this particular controller, which actually very good for battery operated kind of applications. It's also got all these things like drag and drop programming and mass storage via USB. One of the interesting things about Raspberry Pi Pico is that once you connect it the first time with no firmware is being added, you can access this Raspberry Pi Pico just like a flash drive or a pen drive. You can upload the ROM directly onto this device, and automatically it bootstraps onto that ROM after that. Once it's bootstrapped with the firmware, be it MicroPython, for example, you could actually get access to files through MicroPython or through interfaces like Thorny, and you can actually upload and download files to those interfaces. It's also got 26 multifunction GPIO pins. So these headers which are there, all these headers, a majority of them are connected to internal GPIO pins of the RP2040 chip in here. These GPIO pins are the main means for connecting to various devices and sensors. So you can read from sensors, You can send output to some devices, be it a very simple thing like LEDs, or you can also connect to relay modules or any other kind of devices. It could be even motors and so on. So there are different devices available which can be connected to Raspberry Pi Pico. I would say that most devices that work on typical boards like the ESP series boards or even the Arduino boards would also work on the Raspberry Pi Pico as such. It's also got a couple of features like the SPI interface and the I2C interface, which you can see, which will be laid out on this pin. I'll show you the pin diagram in a while, and I'll show you how you can access all the different SPI interface and I2C. There are two SPI and two I2C interfaces available on it, two UARTs, general purpose UARTs, I would say, and it's also got its own analog to digital converter, also called as ADC. There are three 12-bit ADCs available on it. The analog to digital converters can be used to connect to analog devices, be it potentiometers, or it could be any kind of analog devices, and read it in digital format, right? You can convert it to digital format and read it, read the values from them. So it also has 16 programmable pulse width modulated channels, PWM channels. These pulse width modulators are mostly useful for generating oscillating signals, and you can control the bandwidth of it. You can control the pulse width, basically, how long it should be on, how long it should be off. All this can be programmatically controlled through this hardware, which is integrated into this microcontroller. You could also generate pulse widths programmatically in a program by using some sleeps and turning on the pins and turning off the pins manually. But then it's easier to use the built-in PWM channels if all you want to do PWM kind of output, right? So apart from this, it's also got its own internal clock. There's an accurate clock and timer on chip. So if you're looking at accurate timing control and so on, you could actually use this internal clock to do it. It's also got a built-in temperature sensor. This temperature sensor is mostly to sense the temperature of the board itself. I wouldn't want to use it for environmental temperature sensing. I would still connect it to a DHT11 or DHT22 sensor if at all I want to do that. But for checking whether the board is getting hot or not, you can actually use the built-in temperature sensor on board. You also have accelerated floating point libraries on chip, which means that if at all you're trying to do floating point arithmetic, Raspberry Pi Pico has onboard hardware support for floating point. And it's also got 8 programmable I/O state machines, which means to say that you can actually convert a couple of these GP pins or to programmable I/O mode, and you can programmatically generate oscillating I/O or generate your own signals for representing your own protocol if you want to. By the way, if you look at the pinout, which is the more important aspect over here, which you can see that's listed in here. So this is the actual pin configuration with a lot of labels surrounding it here. Now, first of all, I should tell you that if you lay this Raspberry Pi Pico in here, it's not to scale. You can see it's slightly zoomed up. I have a more better, I have another diagram, another page, which has got a more zoomed version of the same pin diagram, which I will show you right here. You can download this separately from in a PDF format if you want to, from Raspberry Pi Pico's website, so it shouldn't be a problem. Now, having said that, if you have this board in here like this, you can see the board, I just put it on top. This is obviously a zoomed version of this same board, which is here. And this is the micro USB connection that you see. And now how you count the pins? The pins are counted from this side. You start from pin number 1. There are 20 pins on this side. You start counting, it's like 1, 2, 3, 4. It goes on all the way till 20. And then after which you start from 21 pin to the 40 pins. So totally there are 40 pins in this. There are 3 more pins which you will find on this corner, but you don't really use it for general programming. These are called as debug pins. The one with the header comes with this pins actually with a small relay gate connector, which is there. You can connect it to a debug cable and debug the firmware in this board. Is meant for debugging the board, figuring out whether the firmware is working fine or not. For that purpose, you use it. But for normal use cases, you generally don't have to worry about these 3 pins. In fact, they're not counted with pin numbers in this board layout. So when you look at the pins which you see here, the first pins that you see, let me just try if you can zoom it a little more. Yes. The ones that are highlighted in green, they represent what we call as the general purpose IO pins, or also called as the GP pins. So you start with GP0, GP1, and the black colored label pin here represents the ground pin. The ground pins are where you connect your supply ground. So when you're connecting this to a power supply, obviously you'll have two wires connected from power supply, right? When you use a DC power source. So the ground actually connects to this ground pin. And there are multiple ground pins. You'll find them here, 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 here. You'll also find them symmetrically placed on top in here too, right? All these places. So you can see this. So you can see a ground in this point, ground in here, ground in this point, ground in here, and so on. If you carefully observe very closely, these labels are written on the board itself, the backside. You can see this right on the backside. Maybe my camera is not able to, there's a glare on my camera, but yeah, I hope you can see this. So if you turn this upside down, if you turn it backside, you can see all these are also labeled on this particular backside of the Raspberry Pi Pico. But my suggestion, when you have the Raspberry Pi Pico with the header, it may not be very intuitive because the header sort of covers some of the pins, so it's not very useful. So it's always better to have a copy of this pinout, maybe another screen on your computer when you're working with Raspberry Pi Pico, or you could also take a print out of this and keep it on the side when you're working on it. So the major means of working with the Raspberry Pi Pico are the GP pins, which I have mentioned in here. The GP0, the GP1, the GP2, GP3, 4, 5. You can see all these are GP pins. So there are totally about 26 of them, I guess. Yes, I think I can count. Yeah, I think it's 28 GP pins, 28 GP pins in here. So there are totally about 28 pins of general purpose IO available on the Raspberry Pi Pico. And you also have the power supply is on the top, which you find here. It's a little confusing. You can see there is a V bus and there's a VSys. The V bus is used when you're using your micro USB connection. If you connect your Raspberry Pi Pico, through the micro USB port, right? Whatever supply that comes from the USB, that is available via V bus. So if at all you connect the V bus onto the common rail on a breadboard, you can actually power all of the devices from the USB power source. It's meant for that. But on the contrary, if at all you want to, power all your devices from the regulated power supply coming from the Raspberry Pi Pico itself, you could connect it to VSys. VSys is the connection from where you can actually connect this pin to your breadboard power supply, and also you can connect other devices. So if you're using breadboard power supply, you want to connect to VSys. But if you're going to be using the micro USB for connecting to the Raspberry Pi Pico and powering it through that, you can use a V bus. Both of them are internally the same voltage. If you connect to V bus, you can still access VSys. It'll give you the same voltage. Generally be about 5 volts, right? It'll be about 5 volt nominally. And alongside with it, you can also see the ground pin right here. So it's quite easy to connect a power supply right into the Raspberry Pi Pico. You just need to supply plus 5 volt here. Plus 5 volt in this place. Hang on. Yes. Plus 5 volt here. And supply the ground pin of your power supply onto this board. There's also a 3v3 EN pin. You don't normally use it. This pin is to enable 3.3 volt supply. So if you turn this on, if this is actually internally, there's a pull-up resistor that actually is enabled 3.3 volt. If at all there are devices that are specifically meant to work at 3.3 volt supply, you can connect it to this particular pin. So from this pin, that's pin number 36 that you see here on the Raspberry Pi Pico board, you can take a wire and connect it to all the devices that are specifically meant to work on 3.3 volt. But if there are devices that are supposed to work on 5 volt, you can connect it to the VSys itself, which is pin number 39. Or you can also connect to pin number 40, assuming that you get a standard 5 volt supply from your micro USB. That is the norm. Okay. This 3v3 enable is already pre-enabled, so with an internal pull-up resistor on the board. But if at all you want to disable that, you can actually connect this to ground. If you short this to ground, if you connect this particular pin to ground, the 3.3 volt output will not be enabled. By the way, all these pinouts from the Raspberry Pi Pico generate 3.3 volt supply. So if at all you have devices which are using TTL logic or any other devices which are specifically meant to use 5 volt, you might need to use some kind of level converters. We call them as TTL level converters. You can use them to convert from 3.3 volt to 5 volt. Even if the devices are sourcing input, that's a more important point. If there are some sensors or devices that's generating input to be used as inputs for Raspberry Pi, you definitely need to use a level converter if they are generating voltages like 5 volts. So because all these pins are designed to take input of 3.3 volt or generate output in 3.3 volt power range. So these are the power sources that you see here. So in summary, if you're going to be connecting your Raspberry Pi Pico through micro USB, the micro USB will source the power. You don't have to worry about special power connections on your Raspberry Pi Pico. But what about other devices you connect to Raspberry Pi Pico? If at all you want to share the same power, you can actually use either the VBus or the VSys and connect it to them. Both will work, right? But if you're going to be using breadboard power supply, the breadboard power supply would look like this. Just one moment. All right, so I just got the breadboard power supply with me. So this is how it looks like. So you'll find this breadboard support supply module available in the market, which makes it easy to power devices from your breadboard through the barrel jack, which you see here, or through the USB connector that can also be connected in this particular power supply module. You can connect this on a breadboard. So if at all you have your typical MB102 breadboard, you can plug this breadboard power supply module on here. Just one moment. I think I need to. There's a parallax problem when I look it up from the camera. Yeah, you can see this right here. So you can see that the breadboard power supply module is connected on the breadboard. And when you do connect it, make sure you note the positive pin connected to the positive rail, negative. So be sure of that. So sometimes you can actually connect it the other side too. And this can get a little confusing because normally on the breadboard, we will treat this as negative. We'll confuse this to be negative. We'll connect this to ground. But apparently the positive is what is connected to this side, right? So you want to make sure that you align them correctly. So when you connecting on the breadboard, you see a positive marking in here. Make sure it sits towards the red side of the breadboard, the red line on the breadboard. And likewise even here. So you can see there's a positive negative in here and a positive negative in here supplied to the breadboard. And this breadboard as usual has a power button. You can power on, power off. Can connect it to a barrel jack to which you can connect from 7 to 9 volt to be safe. So 7 volt to 9 volt is what is taken. I think they support even 12 volt, but I would be a little scary to use 12 volts because I did use a 12 volt power supply in one of these breadboard power supply module, and the first thing that happened when I powered it on is that the regulator chip blew out. So some of the 12 volt power supply modules might supply more than 12 volts, and that could be a problem. So be sure to use 9 volts to be safe. So even if there's 1 or 2 voltage here and there, this will still work, right? So once you connect to this, normally this lane is now fully positive. There's a cut here on the breadboard. So this breadboard might not be very useful because you can see that the lane stops here. You need to put a jumper wire across to connect across the full lane. And you can actually use your Raspberry Pi Pico connected in here, right? In this particular power supply, in this breadboard. And then you can actually connect the positive side of the VSys of this particular Raspberry Pi Pico can be connected to the positive rail, and the ground can be connected to the ground pin. I will show you how that can be done in another example circuit in the future video, right? In the next video. This breadboard power supply can source both 3.3 volt and 5 volt, and that can be configured use this jumper setting. Let me talk about the breadboard power supply later on, but let's focus on the Raspberry Pi Pico itself. So as I was telling you, the pinouts on the Raspberry Pi Pico, let me just zoom this again. So as you can see here, there are the GP pins that are there. You can also see some labels in red. These indicate that these GP pins can be repurposed to use either SPI interface, or you can repurpose these GP pins to use I2C interface. What is SPI? What is I2C? These are the most popular communication protocols that you'd use to connect to various IoT sensors and devices to your Raspberry Pi Pico or Arduino boards, or even your ESP series kind of boards. This is a communication protocol. Both of them send data serially in terms of bits. You have ones and zeros sent as commands and data. And there is a communication protocol that is there for SPI and I2C, which the sensors can detect. The sensors have their own onboard SPI controllers and I2C controllers that can decode this serial connections, the serial data that is being sent across, and work accordingly. How does SPI work? How does I2C work? Is another topic which I will do focus on another video. But for now, SPI actually stands for Serial Peripheral Interface, and the I2C stands for IIC, which stands for Integrated Circuits Communication Protocol, right? So it's meant for communicating between multiple chips using serial line. They have their own multiplexers and demultiplexers to convert the serial to parallel and parallel to serial internally, and they understand the commands and data appropriately on them. So the Raspberry Pi Pico has two I2C controllers and two SPI controllers. You can repurpose any of these GP pins to make it work as an I2C connection or SPI connection if at all you have a device that needs them. For example, I have an OLED display which I will also demonstrate how to wire it up. So you can see it has just 4 pins. There are 4 pins for this OLED display. Actual display, the actual OLED display has lots of pins in here, which you can see, which sort of soldered. And this works with a 4-pin connection onto your Raspberry Pi Pico. So this 4-pin connection is generally either configured as I2C or SPI, and they can be used to send data or receive data. Mostly the 4 pins are for I2C, by the way. Mistake. So if you're using SPI, mostly they'll use more number of pins. I think they'll have at least about 3 to 4 pins, right? Extra. So these 4 pins will contain ground and VCC, and also 2 pins for communicating data and clock. SPI will have some extra pins for chip select and other stuff, which I'll talk about in another video. Now, normally when you want to connect devices like this, you know that this works using I2C protocol. You can connect the I2C data and clock buses to these pins. So you can see most of this I2C. If you see it as I2C, you can see I2C SDA. SDA stands for data, and I2C SCL, which indicates clock, right? So if at all you see a device that's got data and a clock, generally they'll be labeled as SCK or SCL or CLK, depending on the device manufacturer. So whatever is labeled as CLK or SCK or SCL, you connect it to the clock pin of the Raspberry Pi Pico, and what is labeled as SDA or DA or DIN, you might see different labels. You can connect it to the SDA pin. That's for data communication. So you can connect this kind of boards by using these 2 pins, or this is for I2C controller 0. That's why it's known as I2C 0. You can also see an I2C 1 here, which is connected on these 2 GP pins. These 2 can be repurposed as the second controller's I2C pins. The same is repeated across. You can see that I2C 0 is here. You can also find them in here. You can also find them in here. So based on convenience, you can connect the device to these 2 pins, or these 2 pins, or these 2 pins. If at all you want to use I2C controller 0, but if you want to use a second I2C controller, there's another integrated I2C controller on this board. So you can use the other alternate pins that you see here, either these 2 pins, or you could use these 2 pins. I think, these 2 pins, or you could also use these 2 pins, which you can see here. So that's for I2C communication. If at all you have devices that connect via SPI, generally they'll not come with 4 pins. They'll come with 6 pins or 7 pins or 8 pins. Generally it varies, right? Depending on devices. You can see the SPI connections are shown here. The SPI connections kind of represent RX, TX, or CS, that stands for chip select. And you might also have some reset pins. So you'll find them all in here, right? So you have two SPI controllers, and you can repurpose a couple of blocks of GPIO pins to either use SPI 0 controllers pinouts or SPI 1 controllers pinouts, right? You can programmatically control them. So all of these are the pin layouts that you see here. You can also see general purpose UART support. If at all you have some chips which are purely meant for low-level serial port communication, also called as UART, you can connect them over these 2 pins. That means you can repurpose the first 2 pin to work as UART 0s, RX and TX. You can repurpose these 2 pins as pin 6 and pin 7, which is GP4 and GP5, to be UART 1s, TX and RX. The same goes over here. You can see GP, what do I see there? I can see, yeah, GP9 and GP8 and GP9 can be repurposed again as UART1. So it could be repetitive sometimes because depending on how you configure circuitry, if you're using these two GP pins for connecting to some sensors separately, communicating with a standard GP protocol, GPIO interface, you may not be able to use the same pins to connect to another device, right? You have to choose some other pins. But if you're choosing some other pins for connecting to another device and it wants to use, if you want to use I2C, you can repurpose this as the I2C controller, or if it's SPI, you can repurpose this to be SPI device. So that's why you will see multiple labels to decide how you want to make your connection on the Raspberry Pi Pico. And that's about it. I think these are the pin diagrams which you see here. There's also an onboard LED on the Raspberry Pi Pico, which is hardly noticeable if you have the board in here. This is an onboard LED that you see, right? It's a very small onboard LED. You can power this LED on and off. On a Raspberry Pi Pico, it is GP25 is connected internally to this onboard LED. But if you're using a Raspberry Pi Pico W, this LED is not directly connected to GP25, but it goes to another chip, another peripheral, and you can send signals through that peripheral to turn this LED on and off. So the GP pin, GP25 is not used in that scenario on a Raspberry Pi Pico W. And obviously on the Raspberry Pi Pico, you also have a button here. This is the boot cell button. This button is mostly useful for reprogramming the firmware. If you really want to reflash the firmware, there's already a firmware image of, let's say, MicroPython, and you want to remove it and install a new version of MicroPython, the next version of MicroPython, update it. Or maybe you want to just write code in C or C++ and create a program binary through the Arduino SDK, let's say, and you want to just load that binary onto this ROM. You'll normally use a boot cell pin. Normally you hold this pin, connect the micro USB, and it switches to this boot select mode. During this time, this whole device will be shown up like a flash drive. You can just upload the firmware, which is in a UF2 file format, and then the board just reboots once the file is uploaded automatically, and the program that you uploaded seems to run. So normally, if you're going to be using MicroPython, you will actually install MicroPython by holding the boot cell and connecting to micro USB, and then uploading MicroPython firmware on it. On a fresh, brand new board with nothing installed, you don't generally need to press this boot cell key if no firmware is installed. When the board is booted up the first time, the brand new board, it will automatically go to this boot select mode without you having to press this button. So automatically you can upload the firmware the first time. There are also a voltage regulator inside this particular board, which takes care of handling the 3-volt supply. If at all you want to power device from 3 volts, 3.3 volt that is. So you can connect 3.3 volt supply through this particular pin. That's generally pin number 36. So we count from here like pin 40, 39, 38, 37, 36. This is a pin that you see here. This can be connected as supply for various devices that work on 3.3 volt as such. But if your device seems to take 5 volts to operate, you might want to connect it to the VSys pin, which is generally pin number 39. Or if you're connecting your Raspberry Pi Pico via micro USB, you can connect it to VBus, which is coming from the USB power source, right? So this is what you would need to know to work on a Raspberry Pi Pico. So the basic features and the pinouts. So yes, I hope you found this video useful. If you have any questions or doubts, anything at all, feel free to ask them over comments. So I will just answer them when I read your comment. Thank you very much. So hope to meet you in the next video. Next video, I will be talking about how to connect a OLED module. I will be connecting basic LEDs. I will cover that in the next future videos, but why I'm going to be focusing on OLED modules, because many people who have attended my trainings on the Little Wizard Coding Camp were aggressively looking at how to connect the OLED module on this Raspberry Pi Pico, because there are so many different variations. I need to cover that. So I'll be covering that in the next video as such. Thank you very much. So meet you in the next one.